But to give notes for section 4.4, where we're going to learn all about some different types of factoring that we haven't had before. So to start this off, before we start the actual notes, multiply this, pause the video and multiply this out. Hopefully you multiplied it out and got this thing. You might have gotten x squared plus 8. If you did it correctly, your first term was x cubed, and your last term was 8, and everything in the middle added up to 0. Either you did it in a box or you did it with distribution. It doesn't matter. But the pattern here is that when you look at those middle terms, they add up to 0. If you didn't get that, then ask me about it tomorrow, or ask me about it tomorrow or today during asynchronous time. So I can factor and solve polynomial equations, including special binomials. So this is going to be a special binomial. We'll see more of these in a second. And polynomials with 4 terms. So the first one we had was like this, x plus 2 times x squared minus 2x plus 8. Now, if you were to apply the same exact logic to getting rid of all the middle terms, because that means that something special is going on, what would you try to figure out? Would this the next one be x plus 3 times what? What would work out the same way? So hopefully you got this. Well, this x squared is the same. That gives us our x to the third. Instead of 2x, we have 3x with a minus in front of it, just like the x plus 2 and an x plus 3. And we have a 4 in the first one because it's 2 squared, and the second one's 3 squared, which is 9. If you multiply those out, you'd get x cubed plus 27. The next one, x squared minus 4x plus 16, follows the same pattern. So we have x cubed plus 27 and x cubed plus 64. If you multiply those out in a big box, you'll get that to work out. So these are special binomials called difference or sums of cubes, because the middle term is a plus, and the first and last are perfect cubes. X cubed is a perfect cube, and 8 is 2 times 2 times 2, or 27 is 3 cubed, and 64 is 4 cubed, or 4 times 16, 16 being 4 squared, right? So I guess this, if we were to make a pattern for this, it would look like this. A cubed plus b cubed equals a plus b, that's the first number plus the second number, and then a squared, the first number squared, b squared is the last number squared, and then the middle number is a times b. That's the, like we had 2 times x or 3 times x. In this case, a times b. And the sign has to be minus, otherwise you're never going to have anything cross out. Well, difference of 2 cubes is difference of 2 cubes instead of sums of 2 cubes is almost exactly the same, except in this case, the minus is in the front instead of in the second place. So in the first equation, we have an a plus b, and then we have a minus after a squared. And this one here, we can see that it's a minus b, and all the other ones are addition. And you could try that out, and you'll see that you have a cubed minus b cubed. So there's a third one that you should already know. That would be a squared minus b squared. We've seen this over and over again. This is the kind that adds up to 8 or multiplies up to like this, a plus b, a minus b. Like, for instance, if I said, how do you factor x squared minus 25? You'd say x plus 5 times x minus 5, because the middle terms are positive 5x and negative 5x, and they add up to 0. Just the same, and that's our difference of 2 squares, just as a reminder in case you forgot that one. All right. Now let's see what's next. If I can get to the next slide. All right. So if I was going to factor something like k cubed plus 1, you could pause and try this on your own, or you could see it as an example. I think this one's fairly straightforward. The first number, the a value, is k, and the b value is 1, because k times k cubed is k cubed, right? And 1 cubed is 1. So if I said, oh, if I follow this pattern, if I identify k as the a value and b is the 1 value, if you do it like that, you would have k plus 1, because that's a plus b, and you'd have a squared is k squared, ab is k times 1, and b squared is 1 times 1, which is 1 squared. or just k plus 1 times k squared minus k plus 1. Well, so I'd like you to be able to recognize that this is a sum of cubes because you got a perfect cube plus a perfect cube. And then I'd like you to be able to factor it into these two parentheses. So that's an example of factoring a sum of cubes. Here's another one. Figure out what's being cubed and what's being cubed. Take a second, figure out what's being cubed, our a and b values if you're doing it that way. Okay, well, get z to the 6th power, what's being cubed is z squared, because z squared times z squared times z squared is z to the 6th. And 27 is 3 times 3 times 3, so that's what's going on. So our first parenthesis is going to be z squared plus 3. That's our a plus b. And then the a squared would be z squared squared minus ab would be 3z squared. And our b squared would be 3 squared, which is 9. So it kind of looks like this. Right? So that works out like that. Now, if you're having any trouble at all with understanding what I'm talking about, there's another way of doing this, but you have to know this business over here on the right side. You have to know, you don't have to follow a formula. You could do it like this. You do have to know this, though, to start. And it goes like this. It says, let's do the same thing, but let's say if we know that this is z squared in 3 and this is z to the 6th, we can fill in everything else. We'd have to know that this last thing is 27. Right? So then we'd say the diagonals are going to add up to 0. So you'd say to yourself, z squared times what makes z to the 6th? Of course, that's z to the 4th, because z to the 4th and z to the 2nd make z to the 6th. And 3 times 9 is 27, because that's the only thing that's going to make sense for that one. So all we have to do is figure out the middle one. Well, if you do it this way, you'd say 3z to the 4th. Well, the like term with 3 to z to the 4th must be negative 3z to the 4th. And for that to be true, up on top would be z squared times what? Well, be negative 3z squared, right? And that follows the same pattern, but you don't have to memorize the formula if you want to do it this way every time, or if you want to do long division every time. So we have z squared plus 3 times z squared, z to the 4th, which is z squared squared, minus 3z squared, a times b, and b squared, which is 9. You're going to write the answer into 2 parentheses, of course, but that's just another way of looking at it if you'd prefer to do it that way. I don't know why this makes me do it this way, but there we go. All right, so try this one. Pause and try this one. So this one we're using the difference of cubes. So the first number is 3 cubed, so the a value is 3. The b value is 2x squared. Right? So you can follow the pattern, and I hope you got this. Now, if you're getting stuck and you don't want to use the box, you could use the box and you'd have 3 and minus 2x squared on the left side, right? You could do 3 and minus 2x squared on the left side, and then you'd put 27 in the box and negative 8x the 6th. You could work it out from there. If you'd rather do it with long division, of course, you can do it with long division like this. 3 minus 2x squared goes into 27, and then I'd put the minus 8x the 6th over here. You'd say 3 goes into 27 9 times. 3 times 9 is 27. 3 times that thing is negative 18 squared. And notice that I don't have a like term for that. I'm probably going to need a little more space. And then I'd change my pen to subtract. To subtract. All right, and then you'd bring down the next term. So this is gone. You'd have 18x squared. I think I'm going to need an x to the 4th, so I'm guessing I'm not going to need that 8x to the 6th yet. But I'm going to put 0x to the 4th because I have a feeling that's the way this is going. 3 goes into 18x squared. That would be, let's see, 3 goes into 18 plus 6x squared times, right? That'll give us 18x squared, and 6x squared times negative 2x squared is minus 12x to the 4th, as we thought, because there was going to be an x to the 4th going on there. Change signs, and this goes away, and this becomes 12x to the 4th, and bring down the next thing, which is negative 8x to the 6th. 3 goes into to 12x to the fourth. That would be plus 4x to the fourth times. And then when I multiply this out, everything's going to go away. 4x to the fourth times negative 2x squared would be negative 8x to the sixth. So after you change signs, those will go away. So of course it works out the same way. It's just another way of seeing it. If you don't want to learn the formula and you don't want to use the boxes, this is another way of doing it. So it's nice to have choices, but you have to first of all recognize what the difference or sum of cubes is. So let's try another example. You can try it on your own first. Let's see if I can advance the slide first. Come on, never mind me. All right, finally. All right, try this one. Identify it however you're planning on doing, whichever method. Pause. Okay, so I hope that you paused and tried this one because this one's very straightforward. X minus 4, x squared plus 4x plus 16. That's the way that one works, whichever method you use. Here's another one. Please pause. So the first term is 3x, and the second term is 1. So I end up with 3x plus 1, and then 3x squared would be 9x squared. Notice that the first terms have to multiply up to 27x cubed, and the last terms have to multiply up to 1. And the middle terms have to make things go away. All right. So the second type of factoring that we're going to talk about today is called factoring by grouping. And I think we've already touched on this a little bit. In this kind of method, I'd put if there are 4 terms, I'm going to put them all in the box, and I'm going to work to the outside. So for instance, on this one here, 4x squared plus 8x plus 8y plus 2xy plus 2y, I put all 4 of them in the box, and then I try to look for the greatest common factor going across the top. So for instance, 4x squared and 8x, the common factor is 4x. Actually, not just the common factor, the greatest common factor. From there, I can go to the top and say 4x times what makes 4x squared. And then I'd go down to the bottom and I'd say x times what makes xy. That's xy. And then I'd say, oh, what's the top right there? Well, 4x times what makes 8x, and that's going to be a 2. And just to check it, 2 times y is 2y is the last term. So I have 4x plus y times x plus 2 is my final answer. This was fairly simple, I think, working to the outside. Try this one. I put them in the box for you. Try it first. Pause the video. Okay, so over on the left, it's A. The top is B. That's 3. It doesn't matter which order you go in. And you get B plus 3 times A plus 2. Or A plus 2 times B plus 3. It doesn't matter. So if there are 4 terms, they can go into the box and you work to the outside. And it's fairly straightforward. Try this one. Okay, the greatest common factor in the top there is 4x. Now, you might have had negative 4x, and that's fine. All your signs on one of the factors will be different, but that doesn't matter. It'll work out the same way. So this one's 3y. That's a negative 2, and that's a negative 1. Negative 1 times negative 2 makes positive 2 in the final one there. Now, there are times when this doesn't work. If it looks like the last thing doesn't multiply upright, you might have to switch your 2 terms going either across or going up and down. That doesn't happen a lot. It's not a big deal, usually. We'll see what happens with the work that we do. Sometimes you have a greatest common factor, and that's the other thing that we need to be talking about. 32x to the fourth minus 2 has a greatest common factor of 2. So the first thing you do with this kind of problem is you'd multiply the 2 out, and you'd be left with 16x to the fourth minus 1. It's a binomial. There are only 3 binomials that factor into 2 parentheses. Difference of squares, difference of cubes, and sums of cubes. This is a difference. The question is this a square or a cube? 16x to the fourth is a perfect square, so this is a plus b, a minus b. So I get 4x squared plus 1 and 4x squared minus 1, because the middle terms are positive 4x squared and negative 4x squared. Now we're almost done, but we want to just double check to make sure these binomials don't factor. 4x squared plus 1 is a sum of squares. They don't factor. 4x squared minus 1 is a difference of squares. It does factor. Try it first. So if you got 2x plus 1, 2x minus 1, you're correct. So notice that this one has all four factors here with the 2 out in front and the other two things. Here's another one where you're going to have to take out a greatest common factor. Try this first and pause the video. Okay, first thing is you should have gotten a 2xy out of there. If you didn't get a 2xy, do this and then factor the 27x cubed plus 64. Pause the video and factor the binomial. I hope you recognize that it was a sum of cubes. We have 3x cubed and 4 cubed. Those are my a and b values, or however you're doing it.